Welcome to the deep dive. We take dense research, break it down, and give you the stuff you really need to know. Today, we're looking at something, well, it's a real paradox, isn't it? Cooling.
It really is. On one hand, cooling is absolutely essential. It's a lifeline against heat, keeps food safe, protects medicines. It's pure survival, pure adaptation.
But then the way we do it, mostly energy-guzzling air conditioners, it's threatening to overload grids everywhere. And
Yeah.
it actually speeds up the climate change we're trying to adapt to.
A complete contradiction.
Yeah, and the human cost is just staggering. We're looking at potentially billions more AC units, but even so, projections show nearly 3 billion people could still lack proper cooling access by 2050.
Right, and that's the core challenge. We're digging into the UN Environment Programme's big report on this, the Global Cooling Watch 2025, the free degrees. It kind of lays out a roadmap.
So that's our mission for you, the listener. We want to pull out that strategy, find the path to getting cooling emissions down to near zero while making sure everyone gets the cooling they need.
And here's the kicker. The report argues this pathway actually saves us money. Trillions of dollars, potentially.
So not just survival, smart economics too.
Exactly.
Okay, let's unpack this then. We probably need to start with where we headed now, right? The business as usual forecast. Because, well, it sounds pretty grim.
It really paints a stark picture. The report emphasizes this dual reality. We have to adapt. Extreme heat is the fastest growing climate threat out there. It was linked to, something like 356,000 deaths back in 2019 alone.
Wow. So the demand for cooling, it has to go up. What's pushing that surge?
It's a convergence of factors, more people on the planet, obviously,
Yeah.
rising incomes, particularly in developing countries, and then critically, just way more frequent and intense heat waves.
Right.
They measure this using something called cooling degree days, CDDs. Basically, it tracks how much heat stress there is, how much cooling you actually need.
Okay, so those CDDs are climbing. If we just keep going as we are, business as usual, what does that mean for the total amount of cooling equipment, the installed capacity, by, say, 2050?
Under what they call the increased growth scenario, it's projected to more than triple.
Triple.
Yeah, from around 22 terawatts TW in 2022 up to maybe 68 TW by 2050. It's a colossal jump.
Okay, hold on. 68 terawatts, that's the potential draw on power grids, right?
Yeah.
We already see grids struggling during heat waves now. Tripling that. What does that do to emissions?
Well, that's the other shoe dropping. All that extra energy plus the refrigerants leaking from the units themselves,
Yeah.
it pushes global cooling emissions up to around 7.2 billion tons of CO2 equivalent per year by 2050.
And that's up for me.
About 4.1 billion tons in 2022. And remember, CO2 equivalent counts not just the energy emissions, but those refrigerant gases, which are often way more potent warming agents than CO2.
So even if we make AC units a bit more efficient, like current policies aim for, the sheer volume of new machines just swamps any progress. We fail on climate.
We fail on climate, absolutely. But the report stresses it's also a massive failure on equity. Because even with that tripling of capacity, all that strain on the grid, the models still show nearly 3 billion people won't have access to decent cooling in their homes by mid-century.
And these are mostly people in the hottest parts of the world with the lowest incomes.
Precisely. So the business-as-usual path fails everyone. It fails on climate mitigation, and it fails on adaptation for the most vulnerable.
It really underscores the report's conclusion then. We can't just air condition our way out of this mess.
No way. The grid can't take it. The climate can't take it.
Which makes this sustainable cooling pathway they propose, well, not just an option, but kind of the only real choice.
That's the argument. It's ambitious, no doubt, but they model it achieving a 64% cut in projected emissions compared to business as usual, down to about 2.6 billion tons of CO2e.
Okay, 64% reduction.
And crucially, it does this while also getting cooling access to those 3 billion people who'd otherwise miss out.
That sounds like a fundamental shift. How do they actually propose we do it? What's the framework?
They offer two main frameworks that work together. The first is technical. They call it the sustainable cooling hierarchy. It's basically a 4-step sequence for how you should approach cooling design.
A hierarchy. Okay, walk us through it. Step 1.
Step 1 is all about minimizing cooling loads in the first place. Think passive cooling. Better building design, insulation, reflective surfaces, shading, orientation. Stop the heat getting in before you even think about machines.
Right. Attack the problem at the source. Makes sense. What's step 2?
Step 2, use low-energy cooling. If passive isn't enough, bring in the low-energy options. Fans, especially efficient ceiling fans, evaporative coolers. These use just a tiny fraction of the power of an AC.
So you try passive first, then low energy tech. Only then do you consider traditional AC.
Exactly. Step 3 is best energy efficiency. If you do need active cooling like AC, make sure it's the most efficient unit possible. This is where things like minimum energy performance standards MEPS come in. Variable speed compressors, good maintenance, smart controls. Squeeze every bit of efficiency out of the machine.
Got it. And the final step, step 4.
Step 4. Rapid HFC phase down. Use refrigerants with the lowest possible global warming potential, or GWP. This tackles the direct emissions from the refrigerants themselves leaking out.
Okay, that hierarchy seems logical. Build smart, use low power stuff, then if needed, use super efficient clean machines. You mentioned a second framework too, something about tiered access.
Yeah, the tiered access framework, it goes from tier 0 up to tier 5. It's really about ensuring equitable access, especially recognizing the reality in many developing countries. Tier 5 is the goal best in class, often using hybrid passive and active solutions.
Why is that tiered approach so important?
Because of grid constraints. Billions of people live in places with limited or unreliable electricity. For them, a standard power-hungry AC unit just isn't feasible. Even if they could afford the unit itself, the grid simply can't support it.
So for those lower tiers, maybe tier 1 or 2, step 2 of the hierarchy, those low energy fans and evaporative coolers becomes absolutely critical. It might be the only way to provide some relief.
Exactly. The two frameworks really lock together. It's an integrated strategy for both efficiency and equity.
Let's circle back to step 1 then, the passive cooling. Because the report suggests this is where maybe the biggest untapped potential lies.
Absolutely. It gets really interesting here. We tend to think of passive measures as nice add-ons, but the report frames them as the most equitable, most cost-effective first line of defense.
And the impact isn't trivial.
Not at all. Just a single passive measure, say, adding a cool roof or better insulation, can cut indoor temperatures by, on average, somewhere between 1 and 7 degrees Celsius. Depends on the climate and the specific measure, of course.
1 to 7 degrees from just one change. Okay.
But the real power comes when you combine them.
Right.
Strategic combinations, good insulation, plus shading, plus natural ventilation, maybe cool surfaces, they could achieve aggregate temperature drops of 6 to 9 degrees Celsius.
8 to 9 degrees. Wow. In many places, that could completely eliminate the need for any mechanical cooling, right?
For a lot of buildings in temperate climates, yes. Absolutely. It just removes the load entirely. Zero grid impact.
And the report had examples, right? Like combining fans and AC.
Yeah, the hybrid cooling example. They cite an office study box 3.1 in the report, I think. By using fans alongside the AC, they could raise the thermostat setting from 24 degrees C up to 26.5.
Which most people wouldn't even notice if there's airflow.
Exactly. Comfort was maintained or even improved for some. And the result, a 32% cut in HVAC energy use.
32%. Just by using a fan and nudging the thermostat a bit, that feels like incredibly low-hanging fruit.
It really is. And then things like cool roofs, just using reflective paints or materials. The report states they can reduce the actual surface temperature of the roof by 15 to 20 degrees Celsius.
15 to 20 degrees, that's huge heat gain, just reflected away.
Prevented from ever getting into the building.
Okay, so if these passive strategies are so effective, so equitable, so cheap, why aren't they just standard practice everywhere? Mandatory, even. What are the policy gaps?
Well, it's not like there's zero momentum. The report says 134 countries mention cooling in their national climate plans, their NDCs or NAPs, so awareness is growing. But the implementation is patchy. Only 54 countries currently have policies that cover all three key pillars: good passive building codes, strong energy efficiency standards for appliances, MEPS, and a plan for phasing out high GWP refrigerants.
Only 54, so most countries are only doing part of the job.
Right. They might have MEPS for AC units, but weak building codes, or vice versa.
And there's one passive strategy in particular that seems almost universally ignored in codes.
Yeah, it's glaring. Shading. You know, simple things like awnings, overhangs, external blinds. While 69 countries mandate insulation in building codes, which is great, that's passive too, only 19 countries mandate any kind of shading features for new homes.
19. Just 19 countries require shading, even though it's one of the single most effective ways to block solar heat gain, especially in warmer climates.
It seems crazy, right? Governments mandate insulation, but treat shading often cheaper and just as effective, sometimes more so as an optional extra.
And failing to prioritize that first step, the passive step, has massive financial implications down the line.
Huge. Which brings us to the economics. This isn't just about being green. The report makes a powerful case that the sustainable cooling pathway is a massive economic win.
Right. This is key for you, the listener. This isn't just more regulation. It's presented as a huge cost-saving opportunity. Let's get into the numbers. What kind of savings are we talking about?
Okay, first, just the direct electricity savings. By adopting this pathway, the world could save around 8,500 terawatt hours of electricity annually by 2050.
8,500 terawatt hours. What does that mean in dollars?
That translates to roughly US $1.3 trillion in avoided electricity costs every single year.
Wow. $1.3 trillion a year. And the cumulative savings over, say, the next 25 years.
Cumulatively, from 2025 to 2050, the projected electricity savings add up to US $17 trillion.
$17 trillion just from using less power for cooling?
But that's only part of it. Maybe the bigger savings come from the infrastructure we don't have to build.
Ah, right. Avoiding that jump to 68 TW of capacity we talked about earlier.
Exactly. By focusing on passive and efficient cooling, we reduce the peak load, the maximum demand on the grid at any one time. The report estimates this could reduce peak demand by 5 to 10 TW.
And avoiding that peak means?
It means avoiding somewhere between US $13 trillion and US $26 trillion in capital investment. Money we won't need to spend on building new power plants and upgrading grids just to handle inefficient cooling.
$13 to $26 trillion in avoided capital costs. Can you put that into perspective? What does that mean in terms of power plants?
Well, they calculate it's equivalent to not having to build up to 10,000 large power stations. Think about that 10,000 big, typically 1,000 megawatt plants that we just wouldn't need.
10,000 power plants we don't build, don't fuel, don't operate, because we built smarter buildings and used better cooling tech from the start.
That's the scale of the opportunity.
So let's bring it together. What does this all mean? It sounds like the path to near zero emissions from cooling is actually feasible and incredibly financially sensible.
Yeah.
But it all hinges on flipping the script, right? Prioritizing passive first, then low energy, then super efficient active cooling, following that hierarchy. It's not about denying cooling, it's about delivering it smarter.
Precisely. And the report makes one final crucial link.
Yeah.
Combine this sustainable cooling pathway with the wider effort to decarbonize electricity grids globally.
Right. Clean power feeding, efficient cooling.
And the emissions from the cooling sector basically vanish. They project it falls to just 0.2 billion tons of CO2e by 2050. Almost nothing. It becomes a solved problem.
Okay, so we have this pathway. We know passive strategies deliver enormous co-benefits, lives saved, productivity boosted, trillions saved on energy and infrastructure. The report itself calls cooling essential infrastructure, like water or sanitation. So here's the final thought, Shna. If passive cooling is so fundamental, so beneficial, and governments already set mandatory safety codes for buildings, like fire codes, why isn't optimal passive cooling design mandated for all new construction? Why is it still treated as optional or just a minimum standard instead of a core public safety requirement?